Hello and welcome to another Algebra 1 video. This is the third installment of Section 2, thus we call it Section 3, the slope-intercept form of a line. This is a very important section because we're going to use this a lot. This is one of those things that we really want you leaving high school knowing, the slope-intercept form of a line. So our objectives today, we want to identify the slope and y-intercept of a linear function and use them to graph the function. We want to be able to write linear functions in slope-intercept form for a given relationship. And then we want to analyze how a change in a parameter of a linear function affects the graph or the scenario it represents. So when we get down to what the slope-intercept form is, it's an equation that looks like this, okay? And we have y equals mx plus b. And you've probably heard that before. But m, this number, it's in front of the x, okay? And let's be clear on that. That this, the slope is the number in front of the x, okay? Not the number, it doesn't contain the x. The slope is the number that's in front of the x, and it's a measure of steepness, okay? And if you want to know more about slope and how to calculate it, we did that in the last lesson, but this is the measure of steepness. Okay. Okay. And then the next number is the y-intercept. And the y-intercept is the number that doesn't contain an x. That doesn't have an x next to it. Have an x next to it. Okay. And this is the point. Okay, it's the number that doesn't have an x next to it, and it's also the point where the graph crosses the y-axis, okay? So, and it's also, we'll also call it our starting point when we're trying to graph. So this is our starting point, okay? So, all right, let's take a look back over here. Okay, and we just kind of talked about all that. You guys can read through that if you want. And then it says, what is the slope and y-intercept of the linear function y equals negative 4x plus 2/5? So, remember what we know. We know that the slope is the number that is in front of the x, and so I'm going to write over here that my value for m is equal to negative 4. And then that my value for b is the value that does not contain the x. So I'm just going to write that b is equal to 2/5. Okay? All right, so then over here, on this question, it says identify the slope and y-intercept of the linear function in the equation y equals negative 2 plus 1/3 x. Now, here's the thing. A lot of people see it, when we see a linear function, you see it as y equals mx plus b. Well, in this case, you're going to probably assume that negative 2 is your slope because it's the first number. But remember, the slope is the value that is in front of the x, okay? So my slope here, m, is actually 1/3, okay? And my y-intercept is the number that doesn't contain the x. So my value for b is equal to negative 2. Okay, and you can read through this. Yeah, and we just kind of wrote that out. So the correct way, the slope is 1/3 because it is the coefficient of the variable x when the equation is solved for y. The y-intercept is negative 2, and that is because the constant term when the equation is solved for y. All right. The incorrect way to think about it is to say that the slope is negative 2 because it is the first term on the right side. And that's what we were kind of talking about earlier, but we just want to make sure that it's the number in front of the x, okay? Okay, so we want to graph this linear function for this equation, y equals negative 2/5 x plus 3, okay? And so the first thing I want to do is we want to identify the slope and the y-intercept. So my slope, remember, is the number in front of the x. So my slope is the value negative 2/5, okay? And then my y-intercept is the number that's not in front of the x, okay? So my slope-intercept is the value of 3, so b is equal to 3. So the first thing we want to do, this is our starting point, okay? So So I'm going to come over here along the y-axis. I need to locate the value of 3, and I'm going to plot that point right here, that we have a value of 3, okay? Now the next thing I do, it says use the slope to plot the additional point. Now remember, my slope is negative 2/5, and so the slope is either going to be positive, negative, 0, or undefined, okay? And so because the slope is negative, all right, it's going to be going this way, all right? So then I'm going to write this as my rise is negative 2 and my run as 5, okay? And you could do this a number of ways. It doesn't really matter, but I'll show you both ways to kind of generate these next points. And so because my slope is negative 2 over 5, my initial inclination is to go down 2 units. So go down 1, 2 units, and then over 1, 2, 3, 4, 5, and that's where I plot a new point, okay? Now the other way I can do this is I can go up 2, I can go up 1, 2, and then go to the left, 1, 2, 3, 4, 5, and then plot a point, okay? So I use the slope to help me generate new points on a graph, and then I just connect my dots and draw my arrows to show that I have a line, and that's it, okay? But notice that you have, your change in y is negative 2, your change in x is 5. If you look at it the other way, you went up 2 and then you went to the left, negative 5, okay? In either case, you just need to know that the line is going to go this way because it's a negative slope, and that's just what we're looking at. But we use the y-intercept, that's our first point. So, I'm going to label that here. This is our starting point, okay? That's the value that b is equal to 3, okay? It's our y-intercept. And then we use the slope to help us generate other points on that line, okay? And that's the idea, all right? Okay, let's have some practice graphing some equations. And so I'm going to graph the linear function described in this equation. Now the first thing I'm going to do the same thing that I did on the last time. I'm going to identify my slope, which is the number in front of the x, and so my slope m is equal to negative 3. Now I'm going to rewrite this as the slope as negative 3 divided by 1 because I need a rise and I need a run, okay? The next thing I need to do is identify my y-intercept, and so my value for b is equal to negative 2, okay? And remember, this is our starting point. So I'm going to plot that first along the y-axis. And so if I find negative 2 along the y-axis and plot a point, that's my first point. And then the next thing that I have is I have a slope of negative 3 over 1. Remember, my slopes can either be positive, they can be negative, they can be 0, or they can be undefined, okay? And so because we're dealing with a negative slope, I want it to make sure it goes this way, all right? So I'm going to use my points here, and I'm going to go down 3, down 1, 2, 3, and over 1, okay, and plot a new point, all right? And then I can do the same thing as well, and I can come up here and I can go up 3, 1, 2, 3, okay, 1, 2, 3, and then over 1, okay, and then that's where I plot my new point, all right? And I can even keep going with this. I can even go up another 1, 2, 3, and then over 1 and plot a point. Okay, so I have these series of points here that I can help draw this line. You just want to connect them then, okay? And then a few other things that we would like to do is I'd like to plot some points that are actually on this graph. This is the point 1, negative 5. This is the point 0, negative 2. This is the point negative 1, 1. And this is the point negative 2, 4. Okay? And so then, if I plot those points, just over here on the table, okay, we get negative 2 and then 4, negative 1, 1, 0, negative 2, and then 1, negative 5. Okay? And so, pretty easy, not too bad, but pretty standard stuff, all right? But I'm just using the slope and the y-intercept to help me graph this, okay? And so, okay, let's take a look at the next one. All right, so it says, which point lies on the graph of the line? Well, let's go ahead and just graph this and then see what we get. First, I remember, let me draw. We have positive slope, we have negative slope, we have zero slope, we have undefined slope, okay? My slope here is the number in front of the x, so my slope m is equal to 3/4. Okay, my y-intercept b has a value of 5, okay? So my b value is 5. Remember, this is where I start, okay? So I'm going to go here, I'm going to go to 5, and plot my first point, and then I'm going to use my slope, and my slope is positive, okay? So my line's going to go in this direction. So, but I'm going to go up 3 and then over 4 because that's my slope, and I'm going to go up 1, 2, 3, and then over 1, 2, 3, 4, and I'm going to plot a point, okay? And then I'm going to plot the point. What do we got? Let me go down 3 and over 4. So I'm going to go down 1, 2, 3, and then over 1, 2, 3, 4, and plot a point. Okay, and then I'm just going to connect these lines. All right, and the points that I get that are on this graph, this is the point -4, +2. This is the point 0, 5, and this is the point 4, 8. Okay, and so you can label these points over here: -4, 2, 0, 5, and then 4, 8. So then over here, all right, it says which point lies on the graph, and the point that I wrote down was this point over here. Okay, -4, 2, and that's the answer that we'd like to write down. Okay, good stuff. This is fun. I'm having a good time. Okay, now now this one says, write the linear function represented by the graph. So, we've been given the equation and we have to draw the graph, but now we're given the graph and we have to write the equation. Now, the first thing that I'm going to look for, what I need a value for my slope. Let me zoom in here. Okay, I need a value for my slope, and I need a value for my y-intercept. Okay, and once I get those, then I just plug it into the equation. Y is equal to mx and then plus b. Okay, so my y-intercept, I need to locate where my graph crosses the y-axis. So I go to my y-axis and I find that location where it crosses, and that's that point right here. Okay, and that's the point 0, 6. So my value for my y-intercept, my b value is 6. Okay, and that's just where it crosses the y-axis. Okay, then I have to figure out what my slope is. Now, since it's going in this direction, and because we either have a positive slope, a negative slope, a zero slope, or an undefined slope, okay, because it's going in this direction, it's going to be negative, all right? So I'm going to use my 2 points. I'm going to count, and I'm going to go down. I'm just kind of figuring out what these are. The scale is a little off. So I'm going to draw a triangle to connect point to point. And to go from +6 to -4, that's a length of 10, okay? And I'm going to call that -10. And then to go from 0 to 8, that's a value of 8. So my rise is -10 over 8, okay? -10 over 8. Now that fraction can even be simplified. I'm going to write that over here to -5/4, okay? So that's my slope. Here's my y-intercept, and I want to put it together, and I'm just going to substitute these values back into the equation. So I get this. I get y is equal to -5/4 x plus 6, and that's it. And that's all I'm looking for, okay? All right. Okay, let's take a look at this one. This is a practice one. It says choose the answer to complete each statement. So let's take a look at what the slope of the line is. And let's go ahead and just go from one point to the next and identify that slope. To go from -3 all the way up to +4, that's a length of 7. Okay, and then I run and I have a horizontal length of 3. Okay, so remember we either have a positive slope, a negative slope, a zero slope, or an undefined slope. And so because we're going in this direction, I know it's positive. My value for slope is that m is equal to +7/3, okay? And then we need to locate where our graph crosses the y-axis. So let's go to the y-axis, find the point's right here. Okay, and this point has a value of -3 as a y-intercept. So my b value is equal to -3. Okay, so then I write my function, and I write y equals 7/3 x plus -3. Okay, plus -3. And you could even write this in function notation. F of x is equal to 7/3 x and then -3. Okay, either one works. They mean the same thing. Okay, and even though I used a plus negative here, adding a negative is the same thing as subtracting. Okay. Okay, on the last page, the last question, or the first question on the last page says, a snowbank that is 6 inches deep is melting at a rate of 0.5 inches per hour. Okay, and so it wants us to write a linear equation or linear function to model the scenario and identify the domain and range of the function. So here's what I've got. The first thing I want to do is say, all right, I've got an x value, and then I've got y value. All right. Now, and that's to help us identify the domain and range of this function. Here's what I've got. You know, when I'm looking at this, so I have an x value, I have a y value, I need to have a slope value, and I need to have a y-intercept, okay? And so x, we need to think of this as an idea, okay? And I'm just going to draw a graph here, okay? So I'm just going to draw just a generic graph with an x and y axis, and I'm going to use this number here, okay, in the snowbank that it just says that it's 6 inches deep, is melting at a rate of 0.5 inches per hour. This value right here, when it says a rate of 0.5 inches per hour, this is our slope. Okay, and here's the reason why. If I were to think about this, my slope m as 0.5 inches per 1 hour, okay, I'm analyzing two different units here, okay? And remember, a slope is just a ratio of two things, okay? And remember that your slope is your change in y divided by your change in x, okay? So with that, this gives me an idea of what my y values represent, and this is in value of inches. So this is a y value of inches, okay? And that this value, your change in x, represents hours. So that's, you know, typically how I do it, just because it kind of helps me when I can identify the slope. It gives me this measure is inches, okay, and this measure is hours. So I know it's the change in y over the change in x. This is a y value, inches. This is an x value, hours, okay? Now, where do we start at? Okay, well, before we do anything, let's say x is hours, okay, and that y represents inches, okay? Now, where did we start? At 0 hours, okay, how deep is the snow? Okay, and the snow is just 6 inches deep. So I'm going to put a 6 there, and I'm just going to plot a point, okay? And then if I'm going down at 0.5 inches per hour, and let me just write this over here, 0.5 inches per hour, the issue is that you're melting the snow, okay? So when you melt the snow, that means that the number of inches of snow is going to go down. So this is actually going to have a negative slope. So let me put a negative here and a negative here, okay? And what we know is that if every hour it goes down 1/2 of an inch, that means it's going to take 12 hours for us to actually get down to 0. So I'm going to put a big fat 12 over here and plot another point, all right, and draw my line, okay? And the reason how I knew that is because I know that my slope here has to go down 6 and over 12 because my slope has to be 1/2. And so that's, negative 6 over 12, which is the same thing as negative 1/2, which is the same thing as negative 0.5, okay? So that's the idea. And then my y-intercept is just 6, okay? So then my function that I would write is that y is equal to negative 0.5x, okay, and then plus 6, all right? Now, the reason why I wanted to plot these points is because, and have these values on the graph is because this helps us with our domain and range, okay? And the thing of it is that, we don't go down into negative inches of snow, okay? And time is going to stop when we don't have any more snow left. So our domain, goes between 0 is less than or equal to x is less than or equal to 12, okay? And then our range values go from 0 to 6. So 0 is less than or equal to y is less than or equal to 6, okay? And that's how we do that, all right? Okay, on this next one, it says a class of 24 students is planning a field trip to a science museum. The non-refundable deposit is $50 is required for the day-long program, plus a charge of $4.50 per student. It says determine the linear function that models the cost C, okay, and the number of students S, okay? Which statements about the linear function and its graph are correct? So S is like your x value, okay, and C is like your y value, okay? And they use function notation here, but notice how, both of these kind of have similar values, but this one has a one-time fee of $50 and a charge of $4.50 per student. Now, I want you to understand something here. When you see $4.50 per student, you can write that as a ratio, $4.50 per every one student, okay? That is your slope, okay? This represents your slope. That word per here kind of tips you off that that's your slope. Okay, and then a non-refundable deposit, okay, is $50. So you have a one-time fee of $50 plus $4.50 for every student. And what we know, okay, is that, this is the linear model, okay? Now the domain, okay, our maximum cost is going to max out after we've had 24 students, okay? And so our domain is pretty clear that we can, our x values exist between 0 and 24, okay? And so, and I wouldn't even, you could say that is our domain, but we should probably be using the variable s. But we'll see. Okay, the next one says the range goes from y equals 50 to 158. So you have to think, if no students go on the trip, the deposit is $50. It's non-refundable. So you're going to spend $50 either way. Okay, but let's think about the maximum number of costs that this is going to be. And so let's find f of 24. Okay, let's plug 24 into this function and see what we get. And that means that we're taking $4.50, multiplying it by 24 students, and then adding that $50 fee. Okay, so let's calculate this real quick. And we end up getting a y value, a total cost for all 24 students to be $158. All right. And so what we can, what we know from this is that this is our maximum cost. Okay, $50 is our minimum cost, all right? And so we know that the range of cost is going to be between $50 and $158. Okay, and because the graph is a line, we know it's continuous. So the only thing that's wrong is the linear model is this thing, and no, it is not, okay? All right, let's take a look at, got a couple more problems, okay. It says the equation of a linear function in slope-intercept form is written as y equals mx plus b, where m is the slope and b is the y-intercept of the line. Let's take a look at this one. This one's always kind of confusing. What if you had the line y equals x? Okay. Now let's take a look here. The slope of this line, I go up 1 over 1, up 1 over 1, up 1 over 1. Okay, my slope is equal to 1 over 1, which is just 1. And then my y-intercept, this crosses the y-axis at a value of 0. So my b value is 0. So if we plug these into the equation, we get y equals m, which is 1x, and then plus 0. Well, if you look at this, this is just a slope of 1. 1 times x is just going to be x. And then the y-intercept is 0. I'm killing an ant that's on my desk. That can go in the trash. Okay, so, 1 times x is just x, and then you add 0 to that, you don't really need to write that, so you just get the equation y equals x. And a lot of people have trouble with that because they see this and they're like, wait a minute, this is too simple. And the idea is that it's supposed to be simple, but it's just a straight line that has a slope of 1 with a y-intercept of 0. Okay, all right. What I do want to talk about here is that if we change the value of b, okay, if we change the y-intercept, all that does is it moves the graph up or down, okay? And that's all that's happening here. All right, you've just got a graph that's just been moved up. Now these lines, notice that they are parallel and they're not touching. Notice how they have the same slope. We'll talk all about that, okay? And then what happens is that, if we change the value of m, that affects the steepness of the graph. Okay, so, and usually what I say is that the bigger the slope, the steeper the line. Okay. All right, the last thing we have here, it says, consider the graph of the linear function h of x is equal to negative 2/3 x plus 5. Which could you change to move the graph up or down 3 units? So remember, if we want to move the graph up or down, we change the y-intercept. Okay, we don't change the slope. So if we want to move the graph down 3 units, okay, then I would change this 5 to a 2. And I would write h of x is equal to negative 2/3 x plus 2. Okay, this would move it down 3 units. So change the value of b to 2. And that's our answer. Okay, I hope you enjoyed this video. I had a lot of fun making it. That's about all I got. It's good stuff. And I will leave you all with some Michael McDonald, because he is one of the greatest singer-songwriters of our generation in time. Well, not really your generation, and not really my generation. I just really like him.